Assalamualaikum and hi, we are from Group 5 that consists of 4 persons. For this project, we have decided to make a comparison between brushless DC motor and brush DC motor. In Malaysia, most automobiles are powered by internal combustion engines that is using gas or diesel, which will eventually release carbon dioxide that is bad for the environment. One of the best alternatives is replacing the old combustion engine vehicle with electric cars. Electric cars produce zero emission, so they don't contribute to air pollution at all. There are a lot type of motor used in electric vehicle. For example, brushless DC motor, brush DC motor, AC induction motor, and switch reluctance motor. But we have decided to choose brushless DC motor and brush DC motor to compare it regarding the efficiency, cost, maintenance required, reliability, torque speed, and noise level.
Brushless DC motor. The brushless DC motor are built up from the brushes which connected to the commutator. The permanent magnet is fixed at the stator and the winding coil is at the rotor with the iron core. The brushed DC motor have simple working principle because it was based on electromagnetic induction law. A high maintenance is needed because of the brushes wear over time. It also has a high noise level because of the contact between the brushes and commutator. It is cheap because it doesn't require expensive electronic parts. The speed is limited because the brushes wear quickly at high speed application. The brushless DC motor (BLDC) are built up of permanent magnet at rotor while the coil winding is fixed at the stator. The Hall effect sensor is controlling the current direction instead of brush, which is connected to the winding coil. Has higher efficiency than normal induction motor. Low maintenance is required due to the absence of brushes. It has low noise level because there is no rubbing between the brushes and commutator. It requires high cost due to the complexity of electronic circuit. And the Hall effect sensor is expensive. It has no speed limitation as it has no brushes. We are looking at the graph between nominal motor speed against rated power. We can see that the brushless DC motor have higher nominal motor speed at lower power than the brushed DC motor.
I will continue about the explanation about the results and discussion brush DC motors versus brushless DC motors. Due to declining cost and better performance, brushless motors are gaining in popularity in many applications, but there are still places where brush motors make more sense. Much can be learned by looking at the adoption of brushless motors in automobiles. As of 2020, most motors that are running whenever the car is running, things like pumps and fans, have moved from brush motors to brushless motors for their increased reliability. The added cost of the motor and electronics more than makes up for the lower rate of field failures and decreased requirement. As the cost of brushless motors and their associated electronics continues to decrease, brushless motors are finding their way into applications that have traditionally have held by brushless motors. As another example from the automotive world, seat adjustment motors in high-end cars have been adopting brushless motors because they generate less acoustic noise.
For the comparison between brush motor and the brushless motor has a higher energy efficiency, lower electrical noise level, higher rotational speed, lower maintenance, higher durability, and more expensive than the brush motor. For the conclusion, the brushless DC motor have the highest value in terms of efficiency and it required less maintenance due to no brush to wear, but it is slightly more expensive than brush DC motor. One of the most important features for electrical vehicle is durability as you need to use it for a long time. Hence, since there is no mechanical wear occur on the brushless DC motor, it will also increase the lifetime of the motor and the EV in a long period of time. Other than that, it is also environmentally friendly as it produces less electrical noise and more quieter, thus reducing sound pollution. The objective is achieved as we are able to choose the best motor for electrical vehicle and able to make a comparison between the two selected motors.